right, next on the agenda, we have the development and utilization of a cloud-based database and visualization app for pile results and design, PileTrac. And up for this is Kyle Halverson from Kansas. You'll get to know Kyle pretty well because you'll see a lot of him next year. More to come on that.
Yeah. Well, the interpretive dance part of mine is probably not street legal, so I'll keep that to a different date. So, but I'll cue you up when I'm ready to go for it. So, anyway, again, Kyle Halverson. We're in the long session, long titles for papers and presentations. But again, yeah, the development and utilization of a cloud-based database visualization app that KDOT wanted to utilize some. Moving forward, and I appreciate some of the previous talks on utilizing historical information because that is really key to where this goes. So, first of all, I want to thank Foundation Testing Consultants with their assistance on this and their help. The very first presenter yesterday, a young author, was key in the development of this. All right, so to get this started, where we were kind of at with some of this, we'll go back to 2020. I mean, who can't forget 2020, even though we'd like to. But Kansas legislators passed a $8 billion infrastructure program referred to as the Eisenhower Legacy Program. We refer to it as IKE. At that point in time, we had not completed the previous transportation program. And so we were still under construction when everything kind of really shut down. And you can see Kansas, much like every other state, shut down. People were to go home. But KDOT wanted to continue to move forward. Everybody has got these great videos, and this was my example of the best I could come up with here. So anyway, KDOT wanted to continue to move forward. We wanted to continue to design. We wanted to continue to build the current projects. Well, again, we hadn't wrapped up our previous program. So we had 23 accelerated projects that we needed to design and get to construction. One thing that was really evident right off the bat for the DOT was the fact that materials, labor, all that kind of stuff was at a premium. It was hard to get some of that material, okay? So we needed to be better. We needed to evolve. We needed to be better, and that's where really this application and this is the evolution of where we were yesterday and where we're going forward. That to me, that's really kind of the key for this whole thing is our evolution. So we learned that we needed to be more accurate and precise with our pile recommendations. I think it's a problem not just in Kansas but everywhere, predicting that pile tip elevation. Kansas has a significant amount of intermediate geomaterials. It's quite variable, and so we needed to do better. So just like any other really good geology thing, you started a brewery. So the Iron Rail, Casey Jones with FTC, called me up and we kind of just, he had an idea, or just asked what we were doing with all of our historical pile data. Where are we keeping that? How are we utilizing it? And the answer was, the barbecue chimichangas are great here. Have you tried them? But it was something, I mean, we have this data. What are we doing with it? I mean, it's information until you actually use it, and then it becomes data. So we have all this information. It's in ours. We do our own in-house PDA, so we have all this stuff. But how are we utilizing it? How are we utilizing it in a design aspect? And so really kind of started kicking the ball around. He was presenting things that were going over my head, but it just put into perspective some of the things that we currently have that we're underutilizing. So with that partnership with FTC and other consultants within the Kansas City, Kansas area, we're able to try to look at that next. Where's our next step? Where are we going? We don't want to stay stationary. We want to move forward. And so FTC presented this idea of this cloud-based database where we could take all that historical information and start utilizing it in a design aspect, not just necessarily information. Now we can actually utilize it as data. So to kind of start it out was, what's this going to look like? What's it really going to do? So FTC came to KDOT, Kansas Department of Transportation, and they had 50 of their own project sites, and we provided them with 8, and we wanted kind of a proof of concept. How's this really going to work? What are we going to be able to pull from this? Finding common factors within subsurface conditions across the state to better design our pile tips. And the goal for us at KDOT was to be more data-driven with our decisions, not necessarily just a borehole information here and some of this gut feeling type stuff, that institutional knowledge, which is invaluable, but it's nice to have data to back those things up. And then, again, we have all this historical stuff. Let's use it. Let's try to actually do something with it. So the idea is to come up with this relational database. Is what we do is we take our project information, a project number, a bridge number, the bridge location, look at what we've historically put there. Was it drill shafts, spread footings, piling, and this particular project is pile related, so that was the ones that we kind of really focused in on. The construction information, so the as-built information, what we got from our PDAs, what we got just from the inspector in regards to how many blows, what the final loads per pile were, and then taking that information, that as-built, and then as you can see goes to the cloud. And what that is, the cloud is the cloud, so let's just leave it at that. But then from all that, you have this database, right? I'm a visual person. Numbers are just numbers, and then to have this, to be able to see that data in a visualization kind of display really kind of put things into perspective. So kind of the rest of the presentation is going to go into some of the different dashboards and stuff that were created. So this dashboard is just a screenshot of one of the dashboards, and you can look at this and say it's got a lot of really nice colors, but there's a lot of really good information in there. And in regards to pile sizes and physiographic regions within the state and depth at which the pile to get to that rock is, and how many pile we're putting in there. And then there's a depth per pile section by substructure name. And so when we start looking at the state of Kansas in a real generalized physiographic regions, I mean, you got 12 different regions here. Predominantly, most of our pile is going to be in the high plains, Smoky Hills, the Arkansas lowlands, and the Wellington McPherson lowlands. And a lot of those locations there, it's depth bedrock, which drives the justification for pile there. And so as we move through across the state, it really, I think like everywhere else, it determines what your foundation type is. And the goal of what this application can do is draw correlations from the high plains to the Arkansas lowlands. Do we have similar subsurface conditions that we can tie together? Inherently, we kind of know what we're going to do there, but is there a correlation somewhere in there that we can draw to? And so kind of going at the evolution of where we were yesterday and where we're going tomorrow is with our bridge foundation. We do our homework, we find our historical information, we gather that so we know going into the project a rough idea of what we're going to encounter when we go out to do our investigation. We still go out and do the investigation. That is a primary part of what we do. We're providing our bridge design folks with the underlying geology characterization. We give them a recommendation. Is it going to be pile, drill shafts, spread footing, and the hydrology, the site classification, the lat load, and then the engineering geology program. And that was we haven't changed from that, but we're evolving to better do this. So when we went from ASD to LRFD, there was a big change within the DOT in regards to how we perform that field investigation. There's a picture, the one on the left side there, or the drill rig there, that's a 1950s Acker drill. It was we called it the air hammer. It was a pneumatic hammer that drove A-rods into the ground. And on the other side, you can see kind of the parameters that it looked like. If you didn't, it was a timed deal. So if you went for 120 seconds, you went a tenth of an inch, that was refusal. And for ASD standards, for a 10 by 42 H pile, man, that tip was right, it was right on. I mean, plus or minus maybe a foot. At same time, for a 12 by 53, that was a 77 ton. You could load that pile to 77 tons, and it was very, very accurate. Now we've increased the load per pile, and so our accuracy in which that wasn't as good. And then that piece of equipment was 1950. It died. It's no longer in function. It's no longer in use. So how do we take historical information and apply it to today's standards? So we're still out doing our field investigations, doing our CPTs, Shelby tubes, SPTs, rock cores. That's still the primary function of what we do. And this is just some guys out there in western Kansas doing those field investigations for us. And then again, here's just a clip of what that report looks like. You can see where the subsurface descriptions and characterization of the subsurface rock. And then there's on the other side there, it's what our recommendations would have been based on just doing the homework, seeing what your subsurface was, based on your test data, and then kind of gut feeling, institutional knowledge based on what that subsurface was doing with a pile footing at this location. So here's the engineering geology sheet. You can see that I think there's at least 7 or 8 different geologic members at this particular location. We wouldn't be driving pile here, we're probably doing drill shafts, but it was just a display of what we have always done. This is what our bridge designers would get from us. So not only do you get the geologic member there, you also, it's really hard to see, but there's test data associated with that. And that was where we were yesterday. Okay, now today is where we're able to take this, is moving forward, we're able to enter all that information, all that historical information, the information that we do with our field investigation, and now what we're doing with utilizing that historical information, coupling it with our current investigations, and kind of putting it into a centralized location. And when we look at, again, going back to the state of Kansas and the geology, where are the correlations at? Where are the correlations between the high plains and the Smoky Hills, or the Wellington, McPherson lowlands and the glaciated regions? Are there correlations there? And again, this, let's see here, right there, again, exclusively almost piling on every structure. Now, piling is used even down there in the Ozark Plateau, but it's going to be more for an abutment. It's not necessarily going to be at a pure location. That doesn't mean they don't happen there, it's just most common. So inherently we know that it's going to be out there in western Kansas, but we can use it. So how do I draw a correlation between western Kansas and south central Kansas? Subsurface conditions similar? Do I have similar QU values? Do I have similar blow counts, Shelby tube information? Excuse me. And what PileTrac is, and this is just on 2 of those, you can see on the graph there that what we inherently know that the pile, that this is where we drive pile consistently. It also shows that, because the one up there in the upper corner is where we have entered information into PileTrac. So it's correlating really well with what we know, what we inherently know about the physiographic regions within Kansas. So here's another screenshot of what one of the dashboards within this application. You can take, and right there, the one in the middle, the actual plan length that was in the plans versus what was actually put into the ground. Okay, how accurate are we on that? You know, and it's not bad, but you know, we're actually able to, hopefully, with the more data points we get in there, we draw that more onto that trend line. Okay, the ratio of pile lengths versus plan lengths versus required pile capacity. This is the ability that we now have utilizing this, these technologies that we can move forward. And again, there's still the average pile depth per physiographic region. You can see in certain places it's quite a bit deeper than others. So we're able to look at this in a lot of different avenues. There's one on there, price per support kip of pile section type. So there's a lot of different ways that this can be utilized. Now, how our internal staff is using it versus how you may use it is going to be completely different. And this is where it's customizable to its users. This is FTC and KDOT coming together and trying to figure out what's best for us. And this next slide here is one that I think is our internal staff is using quite a bit. This is average penetration into Bedrock. Okay, well, again, I said earlier, we have a lot of intermediate geomaterials. And for example, in south central Kansas, we have the Wellington Shale Formation. It is a very problematic shale, gypsiferous shale. We'll hit a gypsum seam and man, that pile will stop, and then because they're discontinuous, we'll move over, and then that pile will shoot right through. So, it's variable across a pile band, and this isn't giving us, this display here isn't showing us exactly what it's going to do across that foundation element, but we have a better average. Our Kansas contractors, because they were having such a hard time during COVID trying to get materials, and we were delaying projects. They were having to order things, and prices were changing. Not daily. Sometimes daily, if not hourly. I mean, it was that critical to us from a DOT standpoint to work with our Kansas contractors to better refine this. And this is one that our guys were looking at, and they say, okay, I know I'm in this subsurface condition. I can go back and look at 3 bridges within the same county and see the average penetration into it. Because we also add into this our bridge foundation information, so that's all in there. So it's still queryable. We can still find it because it is a database. And this is just the visual representation of some of that information summarized. Here, this, how we're going to utilize this into our recommendations. You can see there, and this is kind of some of where the evolution of this is going to be within the DOT. And on the bottom right there, you can see a 10 by 42 pile and a 12 by 53 pile. We're not asking each one of those piles to do more, but we know a 12 by 53 pile can hold more than a 10 by 42. So are we missing the boat and not putting as much load as we could have on a 12 by 53? That's for our bridge designer. That's not my job, but that's going to be a way that this can evolve into helping them out as well too. Again, the average pile length per supported kip, that you kind of saw that one earlier in a smaller one, but that's on there as well. And then just all the different pile sizes that are common within the state of Kansas. And you can see there's one that really jumps up, and that I think that's a special case, in case you could address that one outside of here. But again, you can see where not a lot of we're not asking more from bigger piles. Is that something we're missing the boat on? This one here, so we looked at a dashboard that showed us penetration into rock. Well, this one's showing us the penetration of pile depth versus depth to rock, and then penetration into that rock. So you can see in some of these locations, because depth to rock is considerable, we're getting quite a bit more skin friction within the soil mound. Even though the subsurface conditions may be different or similar. And others, based on if you're driving into limestone, a weak shale, sandstone, you can see where some of that, you're going into it quite a ways or not. And we can average that. We can look at the top and say, okay, this one's in the same county. Go back, pull that report, query that report, find all this information and help better make our recommendations. So when we look at this entire thing and we say, okay, we're trying to be more accurate and precise with our recommendations, we're able to go to this project and see our top of bedrock, go to a like conditioned location based on that visual representation and draw a better recommendation for our contractors. And now I'll tell you, this is just a screenshot of one. This isn't, we haven't done this one yet, so time will tell if we're actually, I think it's 19 foot to where we set this below the top of rock. We'll see when that project's actually built. So that's where we're at today with this. And like I said, there's the evolution of this and the evolution of the DOT into utilizing certain things like that. There's a dashboard that has been created within that for our inspectors in the field, looking at their hammer sizes, set stroke movement. They can simply go into there and not have to try to do the math really quick using the ENR calculation, trying to figure out what my capacities are right now. They can do a simple, okay, I had a set of this, a stroke of that, with this hammer, I'm in this rough area of capacity. Okay, and again, we looked at it from a standpoint of, right now it's just our geology and geotech folks that are utilizing this right now. Does this move into our field inspection folks? Does this move into our bridge design folks, where we can work together within this same app, this same application? I mean, I think that we are just touching the surface within Kansas DOT of our evolution into utilizing this type of historical information into data, actual data points that we can utilize moving forward. So again, and there's been a lot of presentations and talks, and there was the very first day, I think Jennifer Craven Ross, the utilization of all the historical information that she had to help with her design. What you guys just talked about on the historical information, that's key. We don't have to reinvent the wheel. It's all right here. Let's use it. Now we're able to use data-driven decisions instead of gut feelings. Again, trying to be more precise and accurate with our pile recommendations. It's a problem everywhere. I mean, I guess I should take a poll who has these problems, but I know it's a problem in Kansas, so I can only speak for us. And then the visual representation of that, instead of it just being a queryable and there's elevations or QU values or dry density, elastic modulus, whatever it may be. Now I have a visual representation of what that looks like, and your eye automatically goes to the most extreme, but then you can draw it down to your what really benefits you on that particular project. And then expanding it into many different facets of the agency. I mean, that's where we're trying to, we'll get there, but right now we're still just scratching the surface of where this is today. And from a DOT owner standpoint, and working with our Kansas contractors and our local consultants to do this is just something that we see as a benefit to us moving forward with our foundation recommendations. Thank you. All right, fantastic.
Perfect.
Yep.
No, it's very interesting. So it looks like you have a lot of data that are there, which be in a relational database, which means you figure out what to call things, and you have consistent terminologies and so on. It also looks like you formulated the questions you wanted the data to answer for you first. I'm wondering if you thought about asking the data what questions they answer, and with this database that you have. So somebody could do that and,
Sure.
and find out what correlations are most strongly correlated.
Absolutely.
And it's an exciting database you have, I see.
Yeah. It's a little background. So like I mentioned, the young author that presented on the geophysics and PileTrac. This database originally came to us as a database, and then why don't you guys look at it this way? So those questions and where we're at today, the evolution of this, I think, is, especially when you have somebody has the ability to figure that stuff out and display it in a way that is answering those questions. I think we are setting ourselves up for being better down the road.